All right. Good morning or afternoon, whenever you are. Thank you for joining us on this talk about Lambda. My name is Sean McCullough. I'm excited to be here chatting with you. I kind of picked this one because even though I get paid to do security work, I really love software development. And the times where I've had to build workflows and was able to use Lambda, I loved it. I just thought it was a great tool and a great way to use it inside of my AWS development ecosystem. But there's problems with it and concerns and things that I need to kind of figure out and make sure it works properly and it's tested and all that kind of stuff that we normally would do development. But then there are security implications, and a lot of times we don't think about those when we start building our Lambda. So I wanted to create a kind of a talk that just looks at Lambda, what it is, why you may want to use it, how it kind of works, and then what are some of the pitfalls, and then ways we can detect it and mitigate it. So that's our talk, spooky, scary Lambda attacks. In case you're wondering if this is going to be a Halloween themed talk throughout, yes, it will be very much so. Actually, it's the reason why I picked this month to do it. Just for having fun doing graphic design. I'll say a little bit about me. I'm a cloud security architect with GitHub. I focus a lot on my day-to-day on mitigations and supporting in log collection and threat analysis. But a lot of it is kind of what we've deployed, why we've deployed it, how can we fix it on the cloud perspective. I'm also one of the authors of Security 541 Cloud Security. Oh, I just realized we changed the name and I didn't change it here, but Cloud Security Attack Techniques and Detection Methodology. So that we teach that throughout the year. Loved doing that with two other instructors, both named Ryan, strangely enough, and they are fantastic. Before I did this, before I did GitHub, I spent 20 years at the National Security Agency, focusing on, quote, cyber operations. We used to call it information security, which I thought was a better name, but whatever. And did a lot of blue, red, and hunt and software development. So that's kind of where I got to get this start. I look at my security environment from the vantage point of a software developer. That's kind of how I think. That's my mindset. And so that's kind of how I approach things, especially in this talk. All right. So real quick, what is Lambda? Oh, and by the way, I will have time for questions at the end. So you're welcome to start populating your questions and ask those questions, and I'll hit them at the end. And for some reason, if we run out of time, I'll make sure I type them in and answer them before we close it out. Okay. So just a heads up. Go ahead and ask those questions. All right. So what is Lambda? Amazon came out with this Lambda concept as a way to make it easier for you to create and deploy code without having to worry about the execution of that code. And there had been ways in which we've done that before with, platform as a services might have ways of creating Docker containers and stuff like that. But the Lambda functions were really unique in that they were truly, quote, serviceless. I just said truly, and then I put quote. But the idea that the cloud infrastructure is a service that's being provided to you, and if we are providing a way to give you execution, but we do not let you worry about or have to touch or even understand the execution underneath, then to your perspective, it's serverless. And that's kind of why the name came through. But in Amazon, this created like a kind of whole new flavor of compute and databases and other things where you could just say, I want this thing, but I don't really want to care about how it gets spun up. I want you to take care of that. I'll pay extra for that privilege of not worrying about it. And I have you kind of execute it. So Lambda functions are sets of code. You can be written in Python and TypeScript and I think PowerShell, maybe Rust. There's like a whole bunch of different. Actually, Lambda now you can bring your own execution environment sometimes. So, which I've never really done, but it's possible. But my point is, there's a lot of like base ways that you can deploy this code and write this code, and then you take that code, you give it to Amazon, and Amazon says, okay. I've got this code. I'm going to execute this code, but there's a lot of different ways in which I could tell when to execute this code. I could execute this code when somebody hits an endpoint. I can execute this code when an activity is happening in a stored S3 bucket or a database or something like that, or an activity that's happening inside the environment. I'm going to launch this Lambda function. What's great about this from a software development perspective, when I write code that is kind of small, A lot of the problem is the polling service, like wake up, see if there's anything going on. If not, shut down. Like that code itself can cause problems on the underlying infrastructure, the way I've written it, the way I've deployed, worry about things. And you don't have to worry about any of that. So don't have to worry about how to read a queue. You don't have to worry about polling. All that is just kind of provided to your code. You just have to know how to take that data. I can use Amazon to set up and configure, and I can also get that configuration of how that Lambda is deployed, and I can go and request the code itself, which I actually really like. So I like this idea that I can live inside of this Amazon world. I can hit this Amazon endpoint. I can get data about how this thing is deployed. Oh, it's got these policies. It's got this name. It's running on this kind of execution platform. But I can also make the call and get the code itself if I want to. Running things in Docker, I can't really do that. I can make the call and get the binary, but that's different. I'm not able to get the execution code, which I think I really like about the serverless environments. If I was running a virtual machine, and I was running Docker inside that virtual machine, and I had my containers running inside that, I don't have any way in API through Amazon to say, hey, Amazon, tell me what's running. It just doesn't know. It's your code. You're running it yourself. So being able to do this in Lambda, I have a little bit more easier way to interact with that Lambda code. Lambda is also built for parallel execution. The idea that I got this code, I don't want it to just run once an hour, which I could do, but I can run it a million times a minute. And like really, you can run it a ton of times. I have taken it was a Java-based server application that was having a lot of trouble because they had to keep scaling up the virtual hardware in order to be able to execute this thing as more and more customers came to it. And it was a problem. It was a constant thrashing of trying to get this single piece of code to work. We rebuilt the code as a proof of concept in Lambdas, and we were just like, okay, just do this execution. Now, it wasn't super easy to do. There's a lot of work. But once we get that kind of working, we could scale up and down like within minutes. Like it was crazy what we could demonstrate. We're like, took us this many months, but now I can do this. So I can do this in a parallel manner, and I don't have to worry about a lot of the underlying unmitigated heavy lifting that normally I would have to care about if I'm deploying some kind of infrastructure. So that is kind of the benefits of Lambda. Some people build their entire workloads in Lambda. Sometimes people use Lambda for things like what they normally would do like a cron job for, like to do some kind of cleanup or monitoring. Let's say you want to every hour, you want to interrogate, I don't know, something in your AWS environment and get a report. Lambda is a great place to do that. You can set that on a polling. You can look and see that it's executing right there. I don't have to bury it inside of a virtual machine that has some kind of cron job hoping that it works. So great benefits of using Lambda. So let's walk through the process of kind of creating our Lambda. We will do that with diagrams. My assumption is you have some familiarity with AWS. You maybe have some familiarity with Lambda. I don't really want to go through the screens of it because honestly, the screens change quite often. Every time I go in there, I get surprised by something that's been moved or added. But we want to talk about kind of like the concepts of like how would we do this? How do we approach it? And then what's the security implications of what we've done? So I've got my developer has taken some kind of code and has loaded up into the Lambda. As a software developer, this is great and kind of weird problem. There are ways of building harnesses to execute Lambda code locally on your system. Once you get kind of that set up, it kind of works pretty well, but it's a little bit of work to do it. Actually, I think there's more and more tools come out to make this easier, but doing local code execution can be a little wonky. When I build my Lambda codes for, if I'm doing it for a class that I'm writing or for our production environments or whatever it is, I'm always like looking at, okay, how can I run tests against this in static testing, linting, any kind of like mock-up testing I can do against the system before I kind of check it in. And before I do kind of a smoke test to ensure that it works. So there are ways of doing it locally, but once you have the code you want, you can load that up into your environment. Fun fact, there's actually better inline coding tools available in Lambda now than they were when I started. Before, which is you kind of type it and hope it works. I just recently just saw that like Amazon Q, which is the AI chatbot system that Amazon has. Anything that's Amazon Q is basically their version of Gen AI. But you can actually have that in line and be able to get suggestions and stuff like that for your code, which is kind of nice. So you take this code, you've loaded up, and now I've got code running in a Lambda function, and it is inside of an environment that Amazon is going to execute for you. There's some great talks that Amazon has done where they've shown you how they implement this, how they ensure that they get it so that it works really well, super fast, all that kind of stuff. So I do recommend you go look at that underlying hood. It's really cool what they've done with these micro VMs and basically written this entire platform from scratch. But we don't need to worry about that. So I got this Lambda that's executed. Now I need it to do something. And typically what I want Lambda to do is I want Lambda to interact with some other kind of service. And it works really well if that is some kind of Amazon service usually. So an Amazon bucket or a database, or the bottom thing is a queue. Some kind of Amazon artifact. And when I do this, I can just basically use Bot03 if I'm using Python or whatever the SDK is to say, hey, interact with this bucket and push data to this bucket. Pretty simple, few lines to be able to do that interaction. No problem. Amazon is really designed to work with the Amazon API. If I want it to interact with one of my hosts that needs an IP address, I've got to deploy that Lambda in such a way that has an IP address inside of my environment. It's pretty simple to do that, so it's not a big deal. But for the most part, I have that thing interacting with our other kind of services. Now, I've got this code. I know it's going to interact with a bucket, let's say, but I need some way of getting this Lambda function started. And there's a lot of different ways I can do that. I can have an API in front of it. I can have a web address, which I don't recommend doing. There's much better ways of doing it. Or what I typically are going to do is I'm going to take this Lambda function and it's going to do usually I have a bunch of different Lambda functions. Got a Lambda function that does one piece of the work, and then I send it to another one, and then send it to another one. And I do that for a couple of reasons. One is that in Lambda, you are charged for the amount of resources you specify you need in order for this Lambda to execute and the amount of time it executes. So if I take an entire Java server that I've written, right, and I throw that all into a Lambda function, you probably could do it, but it's going to be really big and really expensive. So it's better to chunk that thing up. It also works really well if you're working on parallel execution. I have a Lambda function. It's going to do something. I want it to do like 1,000,000 times a minute. I'm going to make that code really small, have it execute really fast. 1,000,000 times a day actually is not that expensive. It's like, I don't know how much it is, depending on how size it is, but a quarter or something like that. It's easy. But I want to have it interact with something's going to start this action off. And so I've got this code here. It's, silly code that doesn't do much, but it's going to sort my candy. So I'm going to take candy and I'm going to drop it into a bucket. And then every time something gets dropped into that bucket, Lambda gets executed. Given the information about where that candy is, it goes and grabs the candy file out of that bucket, does some kind of calculation, and then sends it to a bucket or a database or an SNS. The great thing about this, let me pull out my pointer here. The great thing about this is that I specify that, hey, listen, this is how you're going to be executed because of this event. And so from the outside in Amazon, if I look at my Amazon API outside of the code, I can see, oh, this is actually how you trigger it. I can then look at the policies that are in place that specify, hey, listen, you're allowed to look at buckets. In Azure has something very similar, Azure Functions. They don't really highlight it as much. Amazon seems to really be focused on their Lambda. I don't see people in Azure using their Azure Functions as often, but Azure Functions will actually say, hey, this is my input and here's who I've talked to. And it's really great from a security perspective to be able to see what's going in and out of this Lambda function. It's not just code and I have to dig through the code. I can kind of look at it from the outside and see what's happening. So our process is I got files of pictures of candy dropped into an S3 bucket. when that happens, I've told the S3 bucket, hey, anytime you get some new file, I want you to go tell this Lambda. And so that interaction is set up. Lambda goes and grabs the file. Maybe it does a SHA-1 hash or an MD5 hash on it, and then drops the file with the hash information into another bucket, let's say. All right. Pretty simple workflow. Your Lambda function does one thing, does it really well, does it really fast, and pushes it to the next line. And then maybe over here, I've got another item that picks up the file and does something else with it. I can kind of chain these together. All right. In order for me to interact with buckets or databases, I have to give a policy to this Lambda function. So I have to tell Lambda, hey, listen, you are allowed to read and write to buckets, and you're allowed to read and write to DynamoDB, because that's the actions you're going to perform. Those interactions may or may not, well, those interactions of reading and writing to a bucket are not going to go through the standard management API. It's going to be a data interaction with that S3 bucket, but you have to give it permission to be able to do that. So we do that with our policies. And the policies are applied to the Lambda function. I can go look at the Lambda functions and I can see the policy. Now, Lambda function has to be able to interact with the database and the storage account and also the queue in front of it. It also needs to be able to read from the queue. So I should have put that on there, but that the point is that anything that interacts with our environment, I have to give it permission to do. And I do that with policy. So what happens is the SDK that you're running in your Lambda function, you tell it, hey, go put a file to a bucket. That's what you kind of say. And you get a session. When you do that, you have to provide Amazon some information in order to know who it is and be authorized to do it. So what happens is when a Lambda function is created or is executed and it starts up, the secret information, the secret key, access key, the session token, and the access key ID are injected into the environment of the Lambda function. So it already has it right there. So it uses those three pieces of information, interacts with my bucket, interacts with my database, pulls my files from out of my alert out of my queue, and it uses those buckets to interact with the API to do its next step. So if you're not familiar, the secret access key and the session token are both secret. They get rotated pretty regularly. Your access key also will get rotated. Your access key is not really secret, but it's sensitive. If you're doing an investigation and someone's like, oh, the secret's been released, don't write the secret access key in all your documents, but you can write your access key ID. But it needs all three of these pieces of information in order for it to interact with the API. This is a short-term token. This token lives for the amount of execution time of that Lambda function. Lambda functions do stay warm. So once it's executed, it'll hold it for a little bit until in case another execution comes up. If it doesn't, it'll drop it. It'll get a new session token when it needs to. It handles all that under the hood. You don't have to worry about any of that kind of stuff. All right. So that's our primer on what a Lambda function is. What can go wrong? What are some of my problems with Lambda that I need to be looking for? Well, number one, vulnerabilities in the code. All right. So I can write its code. Humans are writing it. Robots aren't doing all the work yet. But I can, I got this code and I've written it and I could do something kind of bad with the code. One of the things I could do is something called a command injection. So maybe I have an API or some other kind of service that takes like this file name and does an MD5 hash on it by hitting the base operating system of the Lambda function and running, the MD5 sum command, right? If I can manipulate the name of that that file name, I could inject new execution into that Lambda function. So that's one example I could do. OWASP Top 10 has a ton of different documentation about like what are some really good or really bad vulnerabilities that are in web code. Our Lambda functions tend to be HTTP influenced is probably a good word. I mean, it's not a web server, but it kind of is a web server. You're usually hitting another API. Maybe you're hitting a web service and you're getting an API that you've written, so you're interacting. But you can write entire web applications with Lambda functions. Pretty simple to do. So it does kind of work as that kind of service. But the point is that you could do something in your code to go and create this problem that you need to go and mitigate. So, what are some tools that we have at our disposal to do that? There's a lot of tools out there that you might be, that's a third-party tool that will do Lambda scanning. One of them now is actually inside Amazon, which is Amazon Inspector. I will tell you, I have problems with Amazon Inspector, especially with the way it scans hosts. I'm not sure if it's the best thing, but I do like it for scanning these Lambda functions, because Lambda functions are, when you think about it, you've got a company, you've got, I don't know, 1,000 people. How many of those people are writing code? They're pushing things to the AWS all the time. There's not a lot of guardrails in place to validate the code before it gets checked in. It's just, and so you got to kind of build those guardrails. And so Amazon gives you ability to turn that on. And one of them is our inspector. Inspector is a whole suite of services that scans the environment to tell you, some specific security problems. It scans hosts, gives you CVE information. It scans Docker containers with the same information. It will also scan Lambda functions. It will tell you if your Lambda function is using a vulnerable library, which is helpful, but it will do deep scans and will tell you, hey, you have an OS command injection. And not only that, but it will give you a recommendation for how to fix it, which you can take, or it's giving you a recommendation that's pretty easy to fix, to evaluate it. I've got this. Well, let me walk through it. I kind of talked about it, but this is a good point here. So what I'm going to do is I got to get an MD5 sum of this file that I've copied out of my bucket. That's a piece of candy. I want to see if it's a unique image. I'm sorting my candy, so that's what I'm doing. And so I'm going to use the operating system to do a process open. I'm going to run the command MD5 sum, and I'm going to just give it the file path of my file. But if I named my file image.png semicolon, who am I? Then what's going to happen is the operating system command is going to say MD5 sum my file, and also who am I, and respond back. And so that's a way that I can get more information out of the Lambda function than I really wanted to. The who am I on a Lambda function, not that big of a deal. But what is a big deal? Let me go back a couple slides. The secret information right here. If I could get my secret information and I could get that and bring that home, maybe I can make use of it to do whatever that Lambda function has been given permissions to do. So I look at this and say, all right, it's an example of something I might want to do instead of doing MD5 sum, in order to be able to ensure that I don't have something beyond a file name split in there. In all honesty, I would probably go even further and just not use operating system popen and basically have my own MD5 hash algorithm in Python or something like that, so that it doesn't try to pull a file name and do this kind of wacky command injection. But the point is that I have a detector that looks at my Lambda functions as they're loaded up into my environment, and it can create an alert that tells me, hey, there's a security issue, not only with a library that you've included, but with the actual code itself. All right, what else can happen? Well, I mentioned just a couple of slides ago that, hey, listen, if the attacker has access to your environment somehow, there's a command injection, they've been able to steal something out of your Lambda function, whatever it is, they're manipulating your Lambda function, however they do it. You could have given it roles that you did not intend to give, and it now has access to do things you didn't really expect it to do. So, for instance, I have a Lambda function, a storage account that I want to read from, and a S3 bucket I want to push to. I'm sorry, I said storage account. I've been doing a lot of Azure lately, but so I have an S3 bucket I'm reading from, and an Azure bucket I'm pushing to. So reading from one, writing to two. But what happens is a lot of times we don't know the names of the buckets at the time we're writing the code, or when the time we're creating our policies, and something's not working, and we're like, I just got to figure this out. So what I'm going to do is I'm going to give it access and just say star buckets and star DynamoDB and star queues, and just I'll fix it later. And do we ever fix it later? No. Have we ever had a time where we're like, ooh, I meant to fix this? Actually happened to me last week or 2 weeks ago. We got an alert. There's this thing that needs to be fixed. And I was like, oh, that's mine. I forgot to go fix it. So it happens to all of us. And so this idea that I have these overly permissive Lambda functions, the Lambda function should do one thing and one thing only: read from this bucket right to the other bucket. That's it. Not all this other stuff. So we see not just in Lambda functions, but we see virtual machines, storage, Docker containers running as like EKS and other things, all being given overly permissive roles. I did a class, this is a long time ago, so it's probably not true for this team, but there was the identity access management team was in the class, and they approve roles. And I don't know if this is true for them, but in my mind, working 20 years in the government, I totally was like, oh, there's a committee of people that stamp whether they're going to allow this role and not. And I was like, oh, if I have to submit something, a request, I'm going to ask for a lot of stuff because I'm going to go through the pain of getting the permissions. So I might as well just ask for all of it. And then hopefully they approve it, and then I can scale it down later. And so depending on how you deploy your environment, how you operate your environment, you could create an environment where it's easy to create overly permissive roles. If I write in something like Terraform or CloudFormation or something like that, if I do infrastructure as code, I can specify what this policy should be, and I can put a star on it, and there'll be no alert that says it happens. If I write in something called CDK, which I'm a super big fan of, I love CDK, although someone just posted that there was some vulnerability with it, so now you gotta look at it. But I love CDK, which is Python that generates CloudFormation. But in CDK, I can say, hey, this Lambda function, you're going to write to here and you're going to read from here, and it will generate the policy for you. That's pretty locked down. But most of the time, we're on our own. And policy writing is hard. Like, it's really, really hard. And so we need some help in some tools. And so there are tools, third-party tools are out there that you can use. I'm familiar with Wiz. Wiz can do this kind of stuff. But also Amazon has a tool that does. It's called the AWS Access Analyzer. The AWS Access Analyzer looks like it was really kind of designed to identify external accesses. So I have a role that people from another account can reach, but it also will let you identify, hey, look at all the things that you have done over the last day, month, 3 months. I think you can go up to 90 days, and compare that with what you're allowed to do. And it will tell you if you have actions you have been given permission to, but you're not allowed to do. So I have a bunch of roles here for the workshops that we had. The cloud team here at SANS has been putting together over this past year, which has been a lot of fun. And I kind of beefed up the roles a little bit to get this to alert. But you could see that, hey, listen, I got this individual role and there's unused permissions. And if I click into it, it will tell you all the unused service, all the services and what actions have not been used. And so you can use that to go and tailor it down. There are other third-party services that'll take this further. It'll give you recommendations of what the policy should be. Wiz would be an example that does that. There are other ones too that do this kind of thing. Then they really try and help. You need another tool to help you with this, this building these IAM roles. They're just hard. Things change over time. You might decide that, hey, listen, I only want to write to this bucket, but next year I might actually increase this to write to 2 buckets, and I may not know the bucket, and it just changes over time, and our policies get stale. We don't always go back and look at them. So tools like this can be really helpful. Another problem we might have are zombie Lambdas, Lambdas that we did not deploy, but are out there running. So if someone were to gain access to your credential ID, we're going to scroll back a couple. I can just click it, I think. So in this environment here in our Lambda function, I have these 3 pieces of information. I need all 3 pieces of information in order for the Lambda function to work, because it's a temporary key. But in AWS, I might have IAM users, which have long-term keys. They don't actually have a session token. And this secret key and this key ID sit around for a while. And there are cases, a lot of cases, where someone accidentally checks this into GitHub or Docker or something like that. And now everybody in the world has access to your access key ID and your secret key, and they can do things inside of your environment. And one of the things they might want to do is use that to spin up things for crypto miners. We typically see that with virtual machines. They tend to be really huge virtual machines, and they kind of look different than what's normally in our environment. But now they're starting to also spin up things like Lambda functions, which are not as efficient of a code like a Bitcoin miner, but they may be harder to detect because they're not running in the same kind of space as a virtual machine. And Lambda functions tend to have weird names, and they're not as recognizable if you aren't familiar with what other teams are doing inside your environment. So I got to be worried about these zombie Lambdas that might spin up, that might do the Bitcoin miner, might give an attacker a backdoor. There have been cases of attackers that are using these serverless capabilities to try and hide from our traditional logging and monitoring, because we've been really focused on, people accessing our virtual machines and our databases. And now they're like, well, I'm just going to spin up SageMaker execution, and I'm going to use that to provide backdoors, which is just brilliant to me. I guess it's bad. I mean, I shouldn't say it's good, but I think it's just a brilliant approach to being able to do this. All right. So I have these three things that, I kind of in my toolbox that comes with AWS. What else can we do? I have logs, kind of. It Lambda logs itself are really actually not that interesting. There's a log generated when your Lambda executed, and then there's a log generated when it's finished execution, and they're really just designed to tell you how much money you spent on that execution. So you can look at it, and it actually will tell you, hey, listen, you asked for 256 megabytes of memory, but you only used 15 megabytes. So it tells you probably should drop this down and make it cheaper. We can do print statements inside of our logs. And that will also create logs that go to CloudWatch. This is really helpful if you are looking for, if you're really good with like exception handling and you're printing out your exception handlers, that might be a really good way to identify that someone's doing some kind of weird command injection. Because if they're doing a weird command injection, or they're doing a vulnerability attack against the environment, you're going to see weird things happen in the logs, and you're going to see your application crashing quite often. Lambda functions crashing are not as obvious as like your giant Java server running on your big VM. When that crashes, like, it's very obvious, usually. I did a research project one time, and our assumption was that if someone's trying to do a fuzz attack in their virtual machine and they're trying these exploits, there's a high likelihood they would cause a blue screen of death. And so we decided inside of this environment, which was a real working environment, but it was for research, we would collect all the blue screen crash dumps, and basically identify, hey, can we see when we try again, it says for this other machine over here, do we see an increase in it? And when we turn it on, we're like getting tons of crash dumps. And it turns out that there was a SharePoint server that was silently knocking over like constantly, and it just kept running, but it was generating these crash dumps. And we were like, oh, we got to go fix that service. But nobody was looking at the results, so nobody really saw that was happening. Lambda can be very much the same way. If it executes and works for your real production environment, you may not notice that something's being knocked over, but you want to have those logs anyways. One problem with doing these logs in Lambda is that you pay for every log you collect. You pay a storage cost, which is actually not that big a deal. But every time that a new log is created, it's charging you for creating that log and sending it to the CloudWatch API. A Lambda function that's executing 1 million times a day, your log collection will be more expensive than your Lambda execution if you have a bunch of print statements. So you want to only do it when you really need to do it for that cost. But really, we mostly are going to catch it when the Lambda function does something it's not supposed to. And usually that's by interacting with, there we go. That's usually when it interacts with some other kind of service. So I'm suddenly have my Lambda function trying to go to this S3 bucket that doesn't really supposed to. My Lambda function, which is a candy sorter, should only read from one bucket and write to another. It should never go and ask for the name of all the buckets, right? And so when I start seeing these activities, or maybe when I'm doing investigation and I see the activity that's happening, maybe I don't see this as a detection, but it's more for investigation. I can see this kind of working. I'm like, oh, wait a minute, this doesn't look right. This is not what's supposed to do. If I have tightly controlled the Lambda function so that it's only able to read and write from those services, it will actually tell me there's a failure. Hey, someone tried to read the names of all the buckets, but it's not allowed to. And that's good. It protected me. It also really highlights the fact that I need to go and investigate. If I have given this thing too much permissions, like we saw earlier, then the attacker has the names of all the buckets and may also be interacting with all the buckets and stealing your data. If the attacker is stealing your data from the S3 bucket, so Candy is really not that sensitive, but let's say this is our sensitive files that we're dropping in there, they may have access to all your data. You won't know it unless you've told CloudTrail, hey, I want you to also collect storage access logs and dump them to this other location, and I've ingested it into my SIEM, or I'm querying it through Athena, whatever that process is, which we talk a lot. We spend a day on that kind of stuff in class. But the point is that the storage logs are not on by default. You have to make a decision to go and turn them on. And then if you have them turned on, you'll know that the attacker who stole the credentials that were overly permissive was able to get to the storage account and read my sensitive files. I like to joke. I'm not a lawyer, so I don't know if this is true, but I always make a joke that if you ever see that there's been a breach and they come out with a statement that says, we have no indication that they stole the data, maybe that's because they don't have their logs turned on, right? So, so you gotta kind of be careful of that. I'm a big fan of turning on my storage account logs. Even though it's a ton of data, we don't normally use it, but when there's an investigation, we do really want to have those. Okay, what else can we do? Positive change management can be really important. Who owns all my Lambdas? If I've got an account that has 20 different teams running inside of it, and they're all building Lambdas, I can't tell from the name of the Lambdas what they are. The Lambdas usually have some kind of awkward, unique naming to them sometimes. They're not always thought through. And so I need to ensure that I've got some kind of tagging a system in place that tags ownership, project ownership of things. So if I, work in an incident response team and I see this Lambda and it's acting weird, I can look at the tag and identify, okay, this belongs to so-and-so. Let me go look at it. Some organizations, every team has their own AWS account. In Azure, it's much more common that every team has its own subscription. So it's kind of easy to tell who owns the resources inside of it. But in AWS, a lot of times AWS folks started way back in the day where Amazon's like, hey, listen, one account, maybe 5 VPCs, that's all you get. And you kind of started in that environment and you might have a lot of stuff running in the same account. So build a tagging team, make sure all your Lambda functions are properly tagged with who owns it, so that when there's an investigation, we can go talk to and say, hey, is this exactly what you think you need to do it? I'm a big fan of leveraging infrastructure as code. I work at GitHub. We do software development for everything. We write scripts it's amazing the kinds of scripts and things that we automate, like stuff that doesn't even need to be automated, but we'll do it anyways. But that's kind of our culture. But before I even joined, I was a really big fan of this infrastructure as code for a couple of reasons. It creates a controlled environment for deploying things, but it also creates a record of who did it. And usually that's because there's some kind of choke point. So if I'm using GitHub, CI/CD pipeline stuff, GitHub Actions and all that, or I have GitLab or some other kind of service, the AWS has code build. I believe that's the code suite of things. I can say, listen, to deploy this Lambda function, I'm going to give that permission to this workload, and I'm going to run through this workload. And then that workload has logging, and I can see when something has changed. So if I'm looking for the zombie attacks, and I realize, hey, listen, this Lambda function was spun up, but not through our change management system, that's an initial indicator that there's a problem, and I need to go and investigate it. So I do like that infrastructure as code. Big thing for me is treat your Lambda function as production, even if it is a toy that does a scan every once in a while and it just kind of works. You don't worry about it. That Lambda function needs to be treated as production for a couple of reasons. If it brings in a package, like a Python package, that Python package might be vulnerable one day. Lambdas and AWS over time basically say, hey, listen, we no longer support this old version of Python. And so you're going to have to upgrade. If you don't upgrade, it'll still work, but you can't actually see your code anymore. It's actually kind of a pain to use. So you're going to have to keep them updated and running and operating. The other thing you might have is GuardDuty, but it's limited for support of Lambdas right now. This is going to change, I'm sure. GuardDuty is Amazon's monitoring service that looks for activity that's happening inside the environment that might be a notification of something's wrong. So it looks for things that are happening as opposed to scanning and looking for posture problems, right? So it's a work cloud workload protection system, I think is the official term for these kind of things. But the excuse me. So the point is that GuardDuty is looking for activity inside the environment, detecting what it's going to do. And one thing that it does is it focuses on network detections. My Lambda function has spun up. It does something. It's a Bitcoin miner. It's going to go talk to some other kind of domain that's not supposed to talk to. And GuardDuty will detect if it is a known bad. So these are atomic indicators of known bad, DNS or IP queries, and it hits that. One nice thing, though, most of the time we don't actually have Lambda running with inside of our virtual private cloud networked environment. We don't sign it to a subnet and all that. Usually we just have it run and it's interacting with the AWS services. So it's in Amazon's kind of IP space. And I have no access to network logs at all. I can't go and grab them. I probably don't want to print everything everywhere it's supposed to go to because that's just like a lot of money, as I mentioned before. But GuardDuty will be looking at network activity to see if it is going to a service that that it's a known bad service. It'll also allow me, and I think it's right in here, custom. Yeah, it also lets me identify IPs that are known bad IP addresses or command and control service or known Bitcoin and, et cetera, et cetera. So not a lot of problems. It doesn't look for like someone attempting to do a fuzz against the service. It doesn't have that kind of interaction with it, but it's definitely looking at the network stuff and network stuff that is really hard to get to. So to wrap it up, make sure that you know the owner of every one of your Lambdas. Scan your code using Inspector or whatever kind of service you might have that you've bought. I'm not trying to pitch one service to the other. It's just Lambda Inspector's there and it's easy to turn on. So if you have nothing, it works. It's pretty good. Turn on. But scan that code looking for vulnerabilities. You pay for that code scanning and the cost can get up there. So you may only want to do this for your production environment. You may not. I mean, you have to kind of make those decisions yourselves for it. But just know that have something looking at your code, evaluate and determine if you've got code in there that maybe is known bad code. I do highly recommend some kind of service, whether it's IAM Access Analyzer or your third-party service that you paid for, but do something that analyzes identity access management policies and compares the policy that's been deployed with the actual needs and provides you with a recommendation. It's a life changer. When you run that thing, you'll be like amazed at what's been deployed inside your environment. Do that. I'm also a big fan of GuardDuty. Doesn't do everything I'd want to do, but it does. It is pretty easy to turn on, and it does a lot of things that I would have written the detections for anyways. And so just turn on GuardDuty. It's just there and works. I love Lambda. It's a great tool in your toolbox. Treat it as you would any other kind of code in your production environment. Make sure you have somebody that owns it. When teams get reorged and people leave, someone picks up that Lambda function, make sure it's been treated, monitored, and ready for investigation if something looks wacky with your Lambda functions. So that is it for the schedule talk. There's only one question. So please jump in there for Q&A. If you have any questions, I'm happy to answer them. There was a question, consider scanning dev or stage environments to detect vulns before they go production. Yeah, that's great. If you have so Lambda function is weird in that you kind of deploy it. You can put it in your environment. You don't actually have to publish it, but you can test it and look at it. And I believe the Lambda and the inspector will look at code that has not been quote published. So you could do it through that. But if you're doing a CI/CD pipeline, usually what we do is you run it in some kind of dev environment that doesn't have any access to the production service. And then you can run your scans on it. Absolutely. Yeah. And do that for your Docker containers and your virtual machines as well. It's a great way of doing that. Any other questions? Going once, going twice. All right. Well, hey, please, happy to connect with you. Reach out. You can ask questions and with me, and LinkedIn is a great place to reach me. Other than that, enjoy your day and have a great week. Thank you very much.